So, good morning. Here we have a simple question. So, just okay. See, in a lossless dielectric medium for which eta equal to 60 pi, eta is intrinsic impedance of the medium, and relative permeability is 1, and h wave is given like this. So negative 0.1 cosine AX roof plus positive 5 plus positive 0.5 sine omega t minus j divided by roof ampere per meter, and he's asking us to compute relative permittivity, angular frequency, and the desired electric field. You see, this case, you have we can treat this first term, okay? This quantity is polarized in x-axis and of course propagating along positive g-axis. And again, this quantity is polarized, okay? This quantity is polarized in y-axis and of course it's propagating along z. The combined effect is what now h. So you know this already. So let's knuckle down for the answer. See, first of all, just identify this. You have a lossless medium, a lossless dielectric medium. So whenever you have this stuff, there is no second thought. First of all, confirm these parameters. If it is lossless, my attenuation constant alpha equal to 0, and there is no conductivity in this case, sigma must be 0. And what is given to you for beta? So see, compare with the general form cos omega t minus beta z, cos or sine, doesn't matter. So cos or sine omega t minus beta z, or you could take the argument as omega t, say minus wave number k naught z. Anything is okay in free space. So now in the coefficient you have 1. So this is 1. So that means beta must be 1. Phase constant beta equal to 1. Attenuation constant for lossless is 0. And conductivity in the case of lossless dielectric medium is again 0. So having said this, now what I can say, intrinsic impedance eta, see, this is given to you already. But I know for lossless medium, eta is equal to mu over epsilon. Okay, generally in general case, what is eta? So you know eta is equal to j omega mu over sigma plus j omega epsilon. So in lossless case, this guy goes to 0. So therefore these two are ruled out and you're left with square root of mu over epsilon. So just plug in. So I have eta is equal to, so just plug in the, so just plug in things here. Eta is given to you as 60 pi. So 60 pi is equal to, I can write it down as follows. Mu is equal to mu naught mu r divided by, this is epsilon naught epsilon r. So this is nothing but mu naught over epsilon naught, and this is nothing but square root of mu r over epsilon r. Now on the left hand side you have 60 pi. So this quantity we know very well. So this quantity is nothing but 120 pi, or you could say it is approximately 377 ohms. Okay, anyways, so let me put it down. You have 120 pi multiplied by mu r is given as 1. So just plug in that. So square root of 1. So square root of 1 over epsilon r. Now you find for this epsilon r. Okay, you find for this epsilon r. So now it's going to be 62. Okay, so epsilon r equal to 4. That's it. So relative permittivity of this particular lossless dielectric medium, whatever, you found this as 4. Okay, so once you confirm this, now let's go for next one. So next parameter we are going to find now. So that is, so we just obtained epsilon r equal to 4. Happy. Now, what next we need to find? We need to find omega and also electric field. So omega, to find omega, which parameter we can make use of to find omega? Because see, I know anyways, whenever I say any medium parameters, this is my medium. So whenever I say you have something like alpha, you have something like beta, and you say conductivity, epsilon, mu. Yeah? So in lossless medium, so among all these components, which component contains angular frequency? Because we're going to find omega, so which component contains that? I know beta has the information about omega, because for lossless or low loss medium, in lossless medium you have beta is equal to omega square root of mu epsilon. Yeah, so beta or wave number both are same for lossless medium. So beta equal to this, I have information of omega in this case. So therefore again same stuff, omega mu naught mu r, epsilon naught epsilon r for mu epsilon. So this is nothing but omega segregate this mu naught epsilon naught for this and multiplied by mu r epsilon r. So therefore, I know very well that velocity of light in free space or vacuum c is equal to nothing but 1 over square root of mu naught epsilon naught, and this is you're going to get 3 into 10 to the power of 8 meter per second. All right. So therefore, this is nothing but omega over c. So this is nothing but 1 over c multiplied by. So I have mu r. This guy is 1. Mu r equal to 1. And just now we obtained mu r equal to 4. So square root of 4 is 2. So now you have beta is equal to 2 omega over c. So from this, omega is equal to what? Beta c over 2. And now beta already we found from the equation, from the H equation, we have beta equal to 1. C, as you know very well, 3 times 10 to the power of 8 meter per second divided by 2. Okay, so you just calculate this. And so 3 over 2 is 1.5. So 1.5 10 to the power of 8. And we are finding for omega. Omega means radian per second. That's it. This is what your beta, or omega. Generally, omega talks, see, omega is not like, for example, you say like 10 megahertz or 1 gigahertz or something like kilohertz. It doesn't talk about that. Omega always tell you, at what rate and what is the rate. I mean, how fast your EM wave is, changing in time. Yeah. So how fast your EM wave is changing in time. So therefore, always, you know what, T gets associated with omega, because the units of omega is radian per second. This tells you like how fast your EM wave is changing in time or per time. So multiplied by again time quantity second. So therefore omega t will give the information about phase. Generally, because you have something like, for example, cos omega t minus say beta z, or I can take like k naught z. Now beta will tell you how fast your EM wave is changing in space, or let's say some distance or whatever space I can take. So therefore I have the units of radian per meter. So therefore you see this, the propagation direction will get associated with this. So it is also in meters. So now beta z is also having the same units, that is radians. Okay, that means this argument, this complete argument is talking about phase. Yeah, phase variation stuff. And anyway, so we are done with omega as well. Now we are left with what? E. Now we need to find this E. What is Mr. E? Now to find this E, now we have two techniques using which we can get this E. All right, what is that? So let's find this. Okay, there. Okay, I can calculate. So E can be calculated. So E can be calculated in two ways. I can just take two ways, right? Now, by using the techniques, okay, based on Maxwell's equations, so that we already developed, okay, or by using, based on those Maxwell's equations technique, you can do. So, anyways, what is the first equation for H? See, I can just do in two ways. Let me solve this in two ways. So let me put it down like this. First of all, let me take my magnetic field. My magnetic field, given magnetic field is this. H equal to, given to us, negative 0.1 cos omega t minus beta z, beta equal to 1. And this stuff is polarized, yeah, in x-axis, propagating along positive g-axis, and plus, yeah, plus you have half, plus half you have sine, and omega t minus beta z, beta equal to 1, so beta z. So now this component is polarized along y-axis. So this component, you have like this 0.5 stuff is oscillating, say, in y-axis, or it is in the direction of y, or polarized in y. So units of H is, very well, ampere per meter. Okay. Now having, we have this H, now how to find E? So we know very well that E and H both have a similar form. The only change is amplitude and phase. Okay, that means I have H stuff. So my E will also behave like, the form of E is also something like H. The only change is what? The only change between these two components you can experience in terms of amplitudes and also phase. So these two components may differ. Otherwise, the form remains same. Whenever I say form like cosine, sine, that form remains same. Only these amplitudes, maybe these amplitudes, or maybe there may be some initial phase or some other a foreign phase, are going to, going to get, going to sit somewhere in the argument. That may be changed. Otherwise, remaining stuff remains. The other stuff remains same. So therefore, let's segregate this into, say, two components. So this is, say, like something like, you have like something like H1. Say it is, of course, I have this AX roof. So therefore, I took this one as a vector, and this component, you take something like H2 vector. Of course, I have EY roof. So therefore, I took H2 vector. That means your H is a combination of two subcomponents, H1 and H2. That means my E will also, as we know very well, they have same form. So therefore, there is no second thought. I can take down my E again of the same form like H, E1 plus E2. Okay. Now let's try to find this E1 and E2 individually from the known H1 and H2. So I know H1, H2 is this. Let me cut this. I just want to cut it. Okay. Now let me go to new page. This is my H, right? So my H is this. So I know this is my H1, this is my H2. So I'm interested for E1. Now I can say, from this I can say, anyways, we have E is equal to E1 plus E2. So I can write down like this, like E1 is equal to, say, like E1 naught, like E1 naught cos omega t. I want to take the same form as H. This is like something like H1 naught, okay, cos omega t minus g. Now, okay, this I'll take it as something like E1, okay. So I just go for E2 now. Let me go for E2. So E2 is equal to, let me take, instead of S2 naught, I'll take something like E2 naught. And I have same form for E as well as like H. So I just take again sine. So sine omega t minus G. So I have AY, I don't know what I'm going to get for this. So therefore, let me take this one as like, sorry, this is my ET component. So let me take it down like this, AE to roof. Now we're going to find out, so what are these two? Okay. Now I know very well, you have a transverse plane, you have some transverse plane like this, and you know you have wave is transverse. The propagation of wave, this is say along positive, because I know my H wave and of course also E wave, they're going to propagate along positive G axis. That's already given here. So therefore this guy is going to become my transverse plane. Your transverse plane is this. So this is your transverse plane. Now you have, this is what your XY plane, or this stuff is your transverse plane. All right. So you have EX or E and H components, they lie on this transverse plane. In its course of travel, you can see the trace of E or trace of H, whatever. I can take trace of E and I can decide based on that what is H, or H, I can decide based on H, I can decide what is E. So that stuff already you know. So now, usually one of the H components is along x-axis. So this is, let me take, this is my X, this is my X, and this is my Y. Okay, you know very well X cross Y, I know very well X cross Y is equal to Z, right hand rule. Okay, just take right hand rule. Now I can take down like this. Okay, X, Y, Z. So what I know, just take right hand rule. So this is what your right hand rule. So I know like this, X cross Y, X cross Y is equal to positive Z. Now see, YZ, next to Z you have X, so therefore I can take Y cross Z equal to positive X. And again, see, after Z you go all the way and you will meet with X, so therefore Z cross X is equal to, then you can have positive Y. This is what a right hand system, already we know this. Now it's very simple to find out if H is along X, okay, and if wave is going along Z, so this must be what now? AE. Yeah, this must be this AE. It's very simple. Otherwise, if we go in terms of what you call like EH, because from pointing theorem you know very well that E cross H, like E cross H, whenever you have cross product, the effect is always normal to it. So you have a vector S, and that means the direction of propagation of wave is transverse or perpendicular to a plane containing E and H components. So E, so H, now say the wave is propagating along direction of K. I can say like this, wave is propagating along direction of K, where K is perpendicular to the plane containing E and H components. So that fact already we know. So therefore, what do? I just follow this. E cross H is equal to say some K. So let me take E, let me take some H. So I know this is positive. So because we know already very well, E vector E is perpendicular to H and this stuff is perpendicular to K. So this fact already we know. So anytime this must be true for transverse electromagnetic wave. So now, now what I can do, I can take right hand system for this. So let me take E like X, Y, Z, okay, whatever. I take E, H, K. So I have something like E, H, K. I'm just taking normalized vectors for E, H, K. Okay. So I know very well what do I do now. Take your right hand system. Come like this. Like E cross H is equal to K. H cross K is equal to E. K cross E. See, this K cross E is equal to H. Okay, so what do you have from this? I know K cross E from right hand rule, K cross E from K you are going all the way to U, so K cross E is equal to say positive H now. But what do you have already? Already I have H. I need to find E. So can I say like this here? Can I say, I can say this one, right? What I can say is E is equal to, I can find out something for E. E is nothing but negative K cross H. I think things are clear. I can say this one, right? Because you see, if I take K cross E, I'll get H. If I take H cross K, I get E. But if I go like this, if I come like this, K cross H, I'm just traveling in the opposite direction. So K cross H must be equal to negative E. So or E is equal to negative K cross H. Now just fix this. Just fix this. I'll go to next page. Mm, Go to next page. See, directly we can put. I'm just elaborating things, nothing else. So, anyways, we are going to find my AE1 of part term 1 and AE2 of term 2. Okay, so of course I have this equation again. Control Y. Okay. So just a moment ago we derived something for E. So what did we do? So we got something like this. So E is negative K cross H. This is what we derived a moment ago. Okay. Now this is what something like, yeah, this belongs to H. So therefore this belongs to H. I can write it like this. This is like AH1 and this is like AH2. Okay. Like this, AH1 and AH2 respectively. Now I want to find the AE1. I want to find the first component AE1. So let me put down like this, AE1. Say I can write it here AZ. Okay, but because the wave is propagating along positive G axis, so I can take K is AZ. Okay, so because propagation is always perpendicular to the transverse plane containing transverse components E and H. So AZ cross, now what is my first component of H? So the polarization, I have AX. Now you just compare with this, the right hand rule for XYZ. Okay, XYZ. So X cross Y is positive Z, Y cross Z equal to positive X, yes or not? Similarly, Z cross X equal to positive Y. So Z cross X equal to positive Y. But wait a minute. See, here I have negative 0.1 cos omega t minus Z AX roof. Okay. So this negative, what I'll do, I'll remove this negative here. I'll remove this negative here. So there is no negative term involved there. So instead of taking negative term there, I'll put negative AX roof here. Okay. So I have negative AX roof. So therefore I put that negative sign here. This negative, let me take this color. So I'll put this negative sign here. So negative, negative, positive. So therefore you see AZ cross, you have positive AX now. AZ cross positive AX is equal to positive AY. That means AE1 must be equal to AY. So finally we found polarization for first component of E. Okay. Similarly, how to find second component here? This must be no doubt AX, right? See, without doing anything, we can say directly X because I know I have XY plane here. This is my XY plane. This is my X. This is my Y, and perpendicular to this or transverse to this transverse plane, you have Z. So variation of propagation, spatial variation of E and H, you can find around Z. All right. So now you just tell me AY is already, this is your AY. H is, so H component is along Y. So E component must be along X axis now. If H component is along Y, E component must be along X. So therefore E cross H is equal to the propagation perpendicular to it, that is AZ. So you have AZ roof, or I can take like this K. So generalization for K vector is like this. I can take K. So don't worry about that. Okay. So therefore, anyways, Anyways, I know E is equal to negative K cross H. I again use the same for this. That is, I want to find AE2. Okay, AE2 is equal to, again, I'm using this one. Okay, now K, instead of K, I take AZ. Wave is going along positive G axis. Now, what is my AH2? AH2 is equal to AY. So I put my AY. Now you compare with this XY plane, transverse means like perpendicular. Transverse to XY plane, you have direction Z or direction K, whatever. Okay. So now you tell me, I have negative sign here. You have AZ cross AY, so Z to Y, but you have Y to Z, not Z to Y. So therefore, if I come opposite like this, if I come Z to Y, this must be equal to negative AX. So therefore, I can say AE2 is equal to, I have this negative sign here, and AZ cross AY is negative AX. So this is equal to positive, fine, this is equal to positive AX. So AE2 is equal to positive AX. So it's very simple. H is along Y, so E must be along X, because always E and H must be perpendicular, okay? Anyways, in lossless medium, there are, of course, they're perpendicular. So we found polarization components for AE1 and AE2 based on AH1 and AH2. So AE1 is equal, is AY, AE2 is equal to AX. So now with this experience, now we do this. Just So I just took like E is equal to, okay, let me compare with this first of all. Okay. So I know my E. So instead of taking this, I'll take like E10. So cos omega t. Already I found, just found what is omega also. So omega t. Now what is AX you have? You have AX here. So what is AE1? Hmm? So anyways, yeah, this is what AY, you found this. And I take this one as something like E2 naught. I'm just taking same form for E, like H omega t minus Z. I got AE2, this is AH2. AH2 is equal to AY. So AE2 is equal to AX roof. So the units for E is volt per meter. Units for H is ampere per meter. Units for E is volt per meter. All right. And I know very well in a given medium, the ratio between E naught and H naught, the amplitudes of E naught and H naught ratio is nothing but intrinsic impedance of that particular medium, eta. All right. So now I just want to find E1 naught. So I just want to find E1 naught. I will take E1 naught over H1 naught is equal to eta. All right. So what is H1 naught here? So this is like H1 naught. Okay. So this is like H1 because already we took this negative sign here, this minus AX roof. Okay. So therefore H1 naught is equal to positive 0.1. So I have E1 naught, we are going to find this by H1 naught is equal to 0.1. And we have eta given in the question. You have eta is equal to 60 pi. All right. So therefore what you get now, so this is E1 naught is equal to finally 6 pi. So multiply this with this, you get 6 pi. So I'll replace this E1 naught by 6 pi. So this is 6 pi. Okay. Similarly, I can take ratio between their amplitudes. E2 naught, H2 naught is equal to again eta. So I have E2 naught equal to, I don't know, I should find it, E2 naught over, I have H2 naught is equal to half, and this must be equal to 60 pi because eta is given to you as 60 pi. All right, so 60 times half, that is 30. So E2 naught is equal to 30 pi. So therefore I'll replace this by 30 pi. Okay, so that's it. So once you know that, So finally, your equation for E is ready. Yeah, your equation for, let me do all these things. Your equation for E. Uh, you want to take, if you want to take a snap of it, you just take, just moving it now. So yeah, this is 35. So let me remove this. Okay. Again, my blackboard is ready. So finally, my E, let me write my clean equation, 6 pi cos omega t minus beta equal to 1 beta z ay plus 30 pi and 30 pi omega t minus z ax roof volt per meter. And further, and further you can make things this way. Further, how can you do? Okay, this is 6 pi. That means you can multiply 3 into 3.1415, so on. You can multiply that stuff and you can put it 6 into again 3.1415, so on. You can do that. And I know my omega is equal to, we found our omega equal to what? So you can plug in omega. We just obtained omega as 1.5 into, we got 10 to the power of 8. So wherever you have omega, just plug in this stuff, 1.5, 10 raised to the power of 8. This is the way how to find for E. Okay. Now you have method 2, how to find E. Method 2 is like this. I'm just going for method 2. All right. So I know you can directly apply your Maxwell's equations. So let me take down my Maxwell equations, say, because I know modified Ampere's law, like curl of H is equal to, I have conduction current density plus displacement current density. Okay, so this curl is not, this curl is dull. Let me take right curl of H. So conduction current density. So Ohm's law says that JC must be sigma E. Of course, I just take this displacement current density is dou T. So this is electric displacement or electric flux density D. So this part you know very well. So it's given already. We are dealing with a lossless medium. So in the case of lossless medium, so I know conductivity. In ideal case, conductivity must be 0. So therefore, means knowing that, I can plug sigma equal to 0. So now you have curl of H is beautiful. You have like source free equation, like curl of H is equal to, you have dou D by dou T. Of course, you are working with a homogeneous medium. Anyways, so from this, I can write like this, curl of H is equal to, I can write, because D is equal to epsilon E. So now, because in homogeneous medium, permittivity and permeability, they are simply constants, or we could say permittivity and permeability, they are functional, they are space independent, or you can say they are position independent and also time independent. So wherever you take, that means this region, within this region, you take this sub-region. Here you have some epsilon. Here also you can have same epsilon. Here also you have same epsilon or mu, whatever. So they don't change with position and time. So that is this assumptions we can make for homogeneous medium. So therefore, I just brought this epsilon out of this partial derivative. So that's the story. So this is what dou E by dou T. So curl of H is equal to this. Now, anyways, you're dealing with homogeneous medium, so no big deal. So I can make my E like this. Okay, if you integrate on both sides, if I apply integration on both sides, you have 1 over epsilon, you have curl of H. Okay, you have curl of H dt. So I can approximate. If I apply integration on both sides of this equation, you will get this. All right. So now I know this may be a lengthy process, but one should know how to tackle down these things also. Okay. So I'll just take curl of H now. So where do I go? So my E is, of course, my E is this. Let me go to second page. Okay. So let me, first of all, let me put down my E. My E is 1 over epsilon integral curl of H dt. Okay, curl of H dt. So now in Cartesian system, suppose you want to find curl of H. So how do you do that? So Ax, Ay, Az. So you have dou x, dou y, dou z, and hx scalar components hy and hg. Drawing straight lines difficult, so let me use this. Okay, so you have this. Now you just tell me at one point, hz must be 0, right? I can take down like that. Why? Because wave is traveling along g-axis. You have transverse electromagnetic wave. This is what your transverse plane, xy plane, and perpendicular to this plane, you have the propagation. Okay, so you have propagation just like this, perpendicular to this plane. So you know very well, already we proved this. So if it is a transverse plane, you have xy components, ex, like ex, hy, ey, hx components, let's just on this transverse plane. The longitudinal components. So the longitudinal components, ez must be 0, hz must be 0. So these components must be 0. Whereas ex, hy, say for example, ex, hy and ey, hx, so these components exist, but these components must be 0. So these are transverse components. So these are transverse components, but these two are longitudinal components. So wherever you have direction of propagation, along that direction of propagation, I can take a wave vector k. A wave vector k always, it's along the direction of spatial direction of propagation. That is, anyways, in this example, we have wave is propagating along z or z axis, whatever. So therefore, it's very simple to take hz equal to 0. So I can take hz as 0. Okay. Now, if you solve it, now if you solve for curl of h, okay, if you solve for curl of h, so curl of h, you're going to get minus dou hy by dou z, and this is ax roof plus you get dou hx by dou z ay. Just the minor for this ax is this. Similarly for ay, az, just find it out, you'll get the answer. It's no big deal in that. Okay. So that's straightforward. You have both hy and hx components involved in this. So what is my hy? What is my hy? I just compare with this now. Okay, we just compare with this. So now my hy is what? What's the expectations for hy? So just you need to this is say like hx component and so like hy component. So this is my hy. Okay, and this component is going to become my, of course, I can include this one as well. So this is going to be my hx component. Yeah, so this is going to be hx component. So I want to derive this component with respect to z. Okay, so if you derive this component, look, let me take this is my h2 naught, this is my h1 naught. So I just take this one as my hy. Okay, hy. So I just perform dou hy by dou z. So if you do this, so what you're going to get now? So I'm going to get h2 naught. I mean, derivative of sine is cosine. So cos omega t minus z. So it's with respect to z. So it's multiplied by 1. Okay. So this is what I have, but we are associating ax roof to this. Okay. So you're associating ax roof to this. This is for this. Similarly, let me cut this one. Let me cut this. Similarly, you have which component? This component. So this is like h is equal to hx ax roof plus hy away roof. So therefore hy, we took this one as hy. Now this is going to become your hx, okay? So you have positive sign. So I have dou hx by dou z away roof. So I'm taking this one away roof multiplied by dou hx by dou z. This is nothing but, so I have cos. So cos becomes negative sign. So negative into negative is positive. So therefore I get, like, let me take, this is like h1, h10 is equal to 0.1. Let me take in general case h10. So derivative of cos is sign, a negative sign, negative and negative is positive. So therefore I take sine omega t minus z, and derivative of z. So derivative of z is 1. So multiply by 1. So now you have to associate this to a way roof because you have a way roof. All right. So that is straightforward. Have this. So now what you do? Just multiply this stuff. I mean, just combine these two quantities, because curl of h is equal to this. Combine these two quantities. Okay, and then what you do now? You have to integrate it. Okay, see, it's a long process. Trust me, if you have patience and if you have stuff, definitely you can do this. There is no big deal. Seemingly, it is a bigger approach, but there is no big deal in that. What is supposed to know? Yes, anyways. So moment ago we found curl of h to be. So you have h2 naught cos omega t minus chat, and we have ax roof plus you have like h1 naught sine omega t minus chat. Yeah, if you still have doubt, just rewind the lecture, just go some 10 seconds or 20 seconds ago. Of course, you have this form. Okay, once you settle down with this form, now, of course, what is my h1 naught? So it's very simple. My h1 naught is negative 0.1. I have this. And h2 naught I can have. Directly I can plug in, but just a mere general form. I have this, just plug in them as it is. Now, what is your E? My E is equal to 1 over epsilon. So 1 over epsilon curl of H. So curl of H dt. So let me put it down like this. 1 over epsilon integration of, what I'll do now, integration of, let me cut this one. Okay. So let me cut this, let me copy it here. So you have this. Okay. So yeah, let me give this bucket. So curl of H. So I give this. This is your curl of H, and you have dt. All right. So what you get now, anyways, h2 naught, you know, h2 naught is 0.5. So let me take it down like this. h2 naught, let me take another color. I take this color by epsilon. What is integration of cos? Integration of cos is positive sign. So you get sine omega t minus z. And of course, you have ax roof. And we are doing with dt. So therefore, I can take this omega here, right? So we can take this omega here now. That's it. So this is what you have. Now again, I have what here? h1 naught. So I have h1 naught by I have this epsilon. Again, I'm doing with t, so I can take this omega in the denominator. So what is integration of sine? Integration of sine is negative cos. So integration of sine is negative cos. I just take negative. So negative cos omega t minus g a y roof. So finally, we got this. Epsilon equal to, what did you get? See, just plug in h2 naught is equal to, you have 0.5. Just plug in that h2 naught equal to 0.5. and epsilon equal to, we obtained something epsilon, so just plug in that epsilon, because epsilon is equal to epsilon naught epsilon r. So epsilon naught, you know, it is 1 over 36 pi 10 to the power of minus 9 farad per meter, or 8.85 10 to the power of 884 farad per meter. And omega we simply obtained 1.5 into 10 to the power of 8 radian per second. Just plug in those values, 0.58, that multiplication with this. Similarly, h1 naught is negative 0.1. We have negative 0.1 just plug it here by, again, same multiplication, cos omega t. So this is what your E. So just compare this E with the method one's E. You will get same answer, exactly same answer. So which of the method, whichever is convenient, you go accordingly, and that's the motivation in solving the problem. Yeah, I hope I'm clear so far. Okay, so hope we're clear so far. Say bye for now. Thank you.